So the first new definition we get here is something called a test statistic. Okay, and a statistic, from before, that's going to be a single number computed from sample data. So in this case, this is going to be a random variable. So in the past, our random variables we've been focusing on lately have been x bar and p hat. So a random variable that is computed from sample data and used in a hypothesis test. So the z-score we just saw above was an example of a test statistic. And a p-value, we've actually computed a lot of these in the last unit. We just didn't give them names yet. But a p-value is a probability. That's actually what the p stands for. But again, that's a really long word to write out, so we're just called a p-value instead of a probability value. That's a probability that the sample result will be at least as extreme as the observed sample result. Given that the null hypothesis is true. So the p-value is always a tail probability. So if we go back and scroll up here for just a second to our picture, okay, here we computed the probability of getting a sample result at least as extreme as the one we got, assuming the null hypothesis was true. So we computed that probability up here. So here's our probability of getting a sample result at least as extreme. So in this case, we were looking at unusually low, so that value or lower, given the null hypothesis was true, and we came up with this number here, this 0.0142. But actually, if we go back to that picture, that is what this is. Okay, this now is the p-value, where this is 0.0142. So I'm just going to write a note here so that when you go back through these notes, you're like, where the heck did we get that? This is computed on the next page. Okay, so these p-values or probability values are these tail areas, these tail probabilities. So every time in the last unit you were asked to compute either a left tail or a right tail area, those probabilities, you were actually computing p-values. We just didn't give them a name yet. All right, so at the end of a hypothesis test, you need to eventually decide, based on what you've seen in the sample data and based on what you know about probability distributions, whether or not you're going to reject the original claim about the population. So again, we're putting together what we know from the sample data, and to make those guesses more educated, we're using probability distributions to make an educated guess about the population. So again, all of these wordings again leading into, again, that definition from the very first chapter on inferential statistics. So keep in mind that as you're doing inferential statistics, you're making educated guesses. Now, educated or not, they're still guesses, and so you may make the wrong decision about the parameter. Even though you did all of your sampling and computing correctly, at the end of the day, you may decide something about the population that isn't actually true. Okay, unusual events do happen, but when we see them, we're going to make the educated guess that the claim is incorrect, even though it might actually be correct. So there are two types of errors that can be made in hypothesis testing. Okay, the first error is if you say that HO is false when in fact it's true. Okay, this means you reject HO when HO is actually a true statement. Okay, so this would be Somebody gives you some piece of information, they tell you some piece of information, you listen to it and you're like, there is no way that could possibly be true, and so you reject that information, but it was actually true. They were actually telling you the truth. Okay, the second error is if you believe that HO is true when in fact it's false. Okay, this is when you fail to reject H0 when H0 is a false statement. Okay, so this is where like somebody tells you a lie and you're like, I kind of believe that, and so you take in this false piece of information and believe this false piece of information. So fortunately, there are two other options that can happen, and hopefully do, so we shouldn't think that every hypothesis test we're going to always screw up in one way or another. So you could reject HO when it's actually false. So that would be a good thing. Somebody gives you a false piece of information and you're like, I don't believe that. Okay, that would be a great thing to have happen. Or you might fail to reject HO when it's actually true. Okay, so that's where somebody tells you some true piece of information and you don't get up all in their face and say you're lying. Okay, so again, believing truthful things and not rejecting, not rejecting truthful things and rejecting things that are actually false. Okay, so the following table organizes this kind of 4-block scenario for you. Okay, so the original statement in the null hypothesis is actually a true statement or actually a false statement. As the person collecting the data, you never know. And even the companies themselves don't know what these values are for their mean lifetimes of all their batteries and so on. They're educated guesses on their part as well. But at the end of the day, after you look at sample data, you get to make one of two decisions. You either decide to reject the null hypothesis or you decide to fail to reject the null hypothesis. Okay, well, if the null hypothesis is actually true information, and at the end of the day you reject that, that would be an error. And if the null hypothesis is actually false, it's a lie, and you fail to reject that lying piece of information, again, that would be an error. Okay, so these are the two different blocks where errors can occur, and we give them really fancy names. Type 1 error and type 2 error. Now, if the null hypothesis is actually false and we look at sample data and decide to reject that piece of information, that would be a good thing to have happen. There's no mistake, no error there. And if the null hypothesis is actually a true statement and we decide not to reject that true piece of information, that also would be a good thing, and so no error has happened here. So this is our 4-block scenario of things that can happen every time we do a hypothesis test. We hopefully land in one of these two no error boxes a lot, and hopefully it's much rarer that we fall into either the type 1 error or type 2 error box.